Hello, I am Bandit Tin Kamrop from the Department of Epidemiology and Biostatistics, the Faculty of Public Health, Khon Kaen University in Thailand. More than 2 decades that I teach statistics to the students. It's not easy to be success. I mean, after a long semester, students seems to get very little. Some seems to remember only a statement about if you have the question, ask the bandit. I mean, after that they just come to me and ask question about that, about what I have already taught in the class. But this way is really successful that I'm going to walk you through the steps that I combine statistical concept and research methodology, means applying statistics in a research by designing a statistical analysis plan for a research. So the first things I like to introduce you is learn from a good abstract. Select some that related to your field of interest. So I put it here in the right-hand side, an abstract from this paper. This is a good one published in New England Journal that has a clear structure, a common structure about the abstract, background, methods, results, and conclusions. So this is a common structure. And within each heading, there are complete components that I can relate this to the left-hand side about the flow of doing a research, and I indicate where statistics play roles. And then I hope you understand about the jargon or some terms in statistics that will be used further so that we can talk the same language. You can talk the same language with your consultant statisticians in future if you like, or if you want to know more, you can be a good statistician. In each, so for example, start with this, the number 1. Every research, we aim for having the end about the conclusions that is very beneficial. Add something to the society, know something new. So I put it here, the body of knowledge. And usually the body of knowledge or knowledge is universal. That means from number 1, we aim to use that or apply that to the larger populations, not only from the study sample. So the first terms in statistics is what is the populations? What is the target populations where the knowledge will be applied to, So sometimes it will be specified, this one, what is the population? It will be specified in the method sections of the full protocol, so that the reader will be clear about is it appropriate or not, or this knowledge can be applied to this group only, for example. So here, it's a study that compare between the groups who receives the experimental vaccine and another groups receive the placebo or the control group. and follow for some time to see the endpoint about HIV infection, and then compare about the rate HIV infection of between the two groups. But that rate, that is not just the difference, but the difference compare with the baseline or vaccine efficacy, or how many percent being prevented by that vaccine, and then conclude that this vaccine may reduce the risk of HIV infection. So the populations in this is anybody who may have the risk of infection, But the study group here is studied in 6 provinces in Thailand, in the provinces in Thailand, not all over the world. So the populations all over the world, because they are at risk of HIV infection, not just only the provinces in Thailand. Okay, so that means if the vaccine work well, it will be recommended to use globally, for example. But the study population is from some provinces in Thailand, and they select some, which is here. So let's start with this one, the conclusions, and then the step after that is not walk this way 1 2 3 4, but work backwardly. That this conclusion need to be based on some evidence, not opinion, right? So after you read a paper, look for what is the difference that is the basis of that conclusion. So this part is called the main findings. And that main finding need to quantify, because quantitative research needs to quantify what? Quantify the magnitude of effect. In this example, it is the vaccine efficacy. In some other example, it may be the measure of association, like the odds ratio, the risk ratio, the hazard ratio, or whatever, And be very careful about this, that a complete presentations need to be comprise both the statistics obtained from the sample of 16,000 or 8,000 approximately per group, that it can prevent about 1/3 of the sample, this vaccine. So it's look promising, right? It can prevent a very dangerous disease, about 1/3. But we cannot rely the interpretations on the statistics that just on that sample, because even this group of the researcher do the same research again, even the same area, but of course different sample, they will not end up with the same magnitude of effect for sure, due to the nature of random or chance. So it will vary from study to study. If we repeat 100 times, 100 studies similar to this kind, it can be vary for sure. And this part then quantify about how sure we are. We are sure, 95% sure or confidence that if we use this vaccine in the populations, it could vary from 1% to 52%. This is called the parameter estimations, or a components of statistical inference that use the statistics from the sample to explain what would happen in the population. And here is the evidence that we need to interpret it so that it will be the conclusions. All right. And another one of the statistical inference is the test hypothesis presented as the p-value. If p-value is less than 0.05, we call it significant. You see, if we are not clear about the concept of statistics, and if we just omit all this and present just only the p-value here, we will tend to say that this vaccine works well. It's significantly preventing HIV infection, because p-value is less than 0.5. And that is why we need to understand concept behind that, which I covered it already in the my lecture in overview statistics. But of course, you need to present in full or complete components, both statistics and statistical inference, descriptive statistic and statistical inference, But interpretation needs to be based on this, the confidence interval, all right? And it needs to be presented. Another one is the endpoint, or the dependent variable denoted by y. This one is essential because it is the one that govern or determine how statistical method, how to analyze the data, or what statistical methods is appropriate for that endpoint. Here the endpoint is HIV infection. It's a dichotomous outcome, infected or not. You see, so it will lead to some guideline, that it is a categorical outcome and some guideline. And if we understand about what is appropriate for dichotomous outcome under this design, okay, if we read the paper, we will know its appropriateness about this and judge about the validity of this one. But if we plan, we will plan it appropriately, right? Another one is independent variable, or X. Here it is about study group or group. The value of it could be 1 vaccine or 2 placebo, just a code for group, like gender, male and female, something like that. So it's really need to understand and present it here clearly. Another one is about the sampling technique, this arrow, from the target populations, how you select the sample. Here is not select, but it's randomly allocated, called randomization. So for observational study, we call sample selection. It could be purposively or randomly. For experimental study, we call randomizations or random allocation. There's a lot of details about this as well, but for this example is here, need to be described. And the last one about how large is the study, or the study size, or sample size. So it is here. So this one, I have covered already the components of statistics from the conclusions, the main findings, and the populations where the findings can be applied to, the target populations or the study target, the sample selection, sample size. The number 4, I will not cover much here, but it's really also say somewhere here about data collections or outcome measurements. For example, here it's measure about HIV infection at the end of 6 months, and every 6 months thereafter for 3 years. That is how the outcome is measured. And from here, there is a step or data management that transcribe the data from the form to a data file. And also we need to understand about that data structure. Usually it's just like a spreadsheet where the first row is the list of variable, and we need to know which one is what, why, which one is usually only one y. If more than one y, we need to know which one is the primary one, the primary outcome. Other are a secondary outcome, but x, there are many usually. So you need to be able to classify the column, which is designated by the name here called variable name, and each row after that is the data. So from here, if we classify each type of variable into groups and know the types, then we will know how to handle in statistical analysis. But whatever we apply to it, we quantify the magnitude of effect with error, and present it as this. Now, you can see it's the main conclusions. Put it here, and then look for or need to present the magnitude of effect. This one means whatever magnitude of effect. For example, here is vaccine efficacy. In some study, it might be, if the outcome is continuous, it might be mean difference, like weight reduction between using green tea or not, for example. Some study could be relative risk, odds ratio, hazard ratio, incidence rate ratio, whatever, and put the magnitude of effect. The first one is the one obtained from the sample. The second one is the one would be found in the larger population, and interpret on this, and then p-value. This actually is optional, like that. So when you plan, you need to present the data just like this, because you still have no data yet. But we know that if we have the data at hand, we will analyze and present in this format. That is the plan. Also, details about these things in methodological section: subject selection, the factors or the independent variables of interest, sample size, and the outcome and outcome measurements, which is very important. All right, so in the background section, provide some information to convince the audience to read further about we are really tackle the important problem, we really know a lot that what have been already known so far about this problem, and what is the gap of the knowledge, you know. And these conclusions need to ensure that it really adds something in the literature, and very important, it needs to be based on an evidence, not opinion, you know. Interpret the correct way, not just the p-value about significance, but how large is the effect, so that we can conclude like this way. And it needs to bridge the gap that being posted at the beginning. So this will look beautiful, just like a sandwich. You know, this is the bread, you know, sandwich, and in the middle is something delicious, you know, precise and clear. So all this is essential for planning statistics for our research, so that we know what components of statistics to be presented where in the abstract. And after that, we expand the abstract to the manuscript. It still preserves these locations in there. And if we don't have the data yet from the mock abstract to the mock manuscript, we can transfer or expand from the mock manuscript to the real research proposal, you know, and make details of these components about statistical planning into more details, and then we get a very good and concise statistical analysis plan for our research.